Hi folks, we want to continue our work on factoring right now, and I'd like to start off with an example we can already do. So let's say you have an expression 2x squared plus 6x. Okay? And I want to factor this, meaning writing it as a product of two other expressions, hopefully simpler expressions. And the way we did that before was we looked for a common factor. So here I look at the two coefficients, and I see that 2 and 6 have a common factor of 2. And I look at the variables, and I see that the variables have a common factor of x. And that becomes the first expression of my product. The second expression of my product will just be what remains once I remove this common factor of 2x. So if I remove the factor 2x from the first expression, well, the numerical portion is just 1. So I don't have to write that down here. And I've removed one of the x factors, so I'm just left with x. And here, when I remove the factor of 2, so 6 divided by 2 is 3, positive 3, so plus 3. And I've removed the factor of x, so there's nothing left here. And that's my final answer. So first of all, we see that it is written as the product of two simpler expressions. And let's just make sure it's actually equal. Let's re-expand. So 2x times x, 2x squared, 2x times 3, plus 6x. So that works. However, what if I start with a different expression? Let's say I start with x squared plus 7x plus 12. Okay? Now here, there's no common factor in the coefficients. These first two terms have a common factor of x, but that third one doesn't. So there's no way to factor this using a common factor. Now let's remember why we're even doing this. If you look at this expression here, or even the one above, these just look like the right-hand sides of quadratic functions. And we're going to see how factoring the right-hand side of a quadratic function will be helpful in finding some important characteristics about that function. So that's why we're doing it. Let's now see how we can do it. And to do that, I'm going to start in a similar way that I did when I learned about common factors. As I go backwards, I'm going to take something that is already in factored form. Okay, so I'm going to take x minus, let's say x plus 10, okay, and we'll multiply that by x minus 7. So this is in factored form because it's the product of two expressions, in this case here two binomials. So let's go backwards. Instead of factoring, we'll do the opposite, which is expanding. So let's multiply this out. So let's FOIL it. X times x is x squared. X times negative 7 is minus 7x. 10 times x plus 10x. And then 10 times negative 7, negative 70. Okay? So what we have here is now the expanded form. Okay, and I want to relate this expanded form to what I started off originally. The first thing I'm going to look at is this number negative 70. How did we get that negative 70? We realized that we got it by multiplying the two last terms in our binomial. And I want to focus in on these two last terms in the binomials. So I'm going to give them a name here. I'll call this one n, and we'll call this one m. So this last term is just gotten by multiplying n times m, okay, because 10 times negative 7 gives me negative 70. And these middle terms, the ones we're always able to simplify because they're like terms, okay, and the way we simplify like terms is just by adding or subtracting the coefficients. Okay, the variable doesn't change. So the coefficient here of x is just going to be negative 7 plus 10. Okay, in other words, m plus n. Okay, so our final answer will just be x squared. Negative 7 plus 10 is positive 3, so plus 3x, and then minus 70. But this expression looks a lot like the one I was trying to factor earlier. They have the same form. In fact, they have that form of the right-hand side of a quadratic function. Okay? So our goal now is to see how can we go from this expression into the factored form. Okay? And this work in the middle gives us our hint. Okay? We notice that this last expression, this last term, is going to be the product of the last terms of our binomial, and this middle term has to be the sum of the two last numbers in our binomial. And we're going to use that to help us solve these problems. Okay, so if I have x squared plus, and let's try to come up with a rule that's more general. So if I have x squared plus bx plus c, you'll notice here there's no coefficient in front of the x squared. We are going to find ways to factor expressions that do have a coefficient to the x squared. It's just a little more complex, so we're going to save that for afterwards. Okay? And I want to rewrite this as x plus m times x plus n. Okay? And using the pattern we saw earlier, we see that the b value has to be the sum of our two last terms, and the c value has to be the product of our two last terms. And let's see how we can put that into action. Okay, so let's take this example here. In fact, let's take the example we started with, x squared plus 7x plus 12. So x squared plus 7x plus 12. Okay, so our goal here is to find two numbers, we'll call them m and n, that multiply to 12 and add up to 7. Now, we have to start finding these numbers. Now, there's a lot of numbers that add up to 7, because there's, 2 and 5, 3 and 4. There's also -1 and 8, -3 and 10. There's tons of pairs of numbers that add up to 7. I can find as many as I like, but there's not a lot of numbers that multiply to 12. And so this is the operation I want to start with. So I'm going to think about all the numbers that multiply to 12. Okay? So here, let's go with the easiest one, 1 and 12. Okay? Well, let's see, I've got 2 and 6. And then I've got 3 and 4. And that's about all of them. So here we see there's only 3 options for pairs of numbers that multiply to 12. What I have to figure out is if I add up these numbers, can I somehow get to 7? And I realize that if I add 1 and 12, well, there's no way to get 7. If I add 2 and 6, no, that's equal to 8. That doesn't work. But I notice that 3 plus 4 is equal to 7. So I found two numbers that add up to 7, the middle term, and multiply to 12, the last term of the expression. And so, according to what we saw earlier, it looks like my factorization will be x plus 3 times x plus 7. And the way we can check, x plus 4. Sorry about that. 3 and 4 were our numbers. So let's see if that works. Let's FOIL it. X times x, x squared. Let's do the outsides and the insides. X times 4, 4x plus 3x, 7x. And 3 times 4, 12. And so we're on the right track here. It looks like we found our method. So let's just do a couple of more examples here. All right. So let's see. Let's take, how about this one here? Let's take x squared plus 4x minus 12. Okay. Let's take something that has a subtraction here. Okay. So we're looking for m and n. Okay. And m times n has to be equal to our c value here, -12. And m plus n has to be equal to our middle term, our b value here, which is 4. Okay. Now, I notice I'm going to keep in mind that this product is -12. That means one of these has to be positive and one of these has to be negative. Okay, but let's just list again our factors of 12. So again, we have 1 and 12. We have 2 and 6. We have 3 and 4. So as I'm looking for combinations, I have to remember that one of these has to be negative. So if I take 1 and 12, well, there's no way to combine them to get 4. So that's out of the picture. I look at 2 and 6, and I remember one of these would have to be negative and one would have to be positive. Is there a way to combine them to get an answer of positive 4? And I could check on my calculator or think about it in my head, and I realize that negative 2 plus 6 is equal to 4. And so my numbers must be m equals negative 2, n equals 6. So I add them up to get 4, and I multiply them to get negative 12. So my factorization here would be x minus 2 times x plus 6. Let's see if it works. X times x, x squared. 6x minus 2x, there you go, 4x, that works. And negative 2 times 6 is equal to negative 12. Okay, so here again, we've succeeded in taking this expression and factoring it into a product of two other expressions. Okay, let's go again. Let's take x squared minus 5x plus 6. So again, make my list here, m times n. Okay, I'll try to write a little less this time. We'll say, do some of it in our heads here. I know that m times n has to be equal to positive 6. So let's write out our possibilities. 1 and 6, 2 and 3. Okay, so multiply to 6, perfect. We need it to add up to negative 5. Now here, remember, they have to multiply to 6. So they could both be positive, but they could also both be negative. This is where you think, well, in order for the addition to be equal to negative 5, they must both be negative. So I'll just add some negatives here just to help me out. And let's see what happens here. If I have negative 1 plus negative 6, well, that's like negative 1 minus 6. Well, negative 1 minus 6 is equal to negative 7. That doesn't work. Let's take this one here. Negative 2 plus negative 3 is like negative 2 minus 3. And negative 2 minus 3 is negative 5. So that works. So my two numbers are m equals negative 2 and n equals negative 3. And so my factorization would be x minus 2 times x minus 3. And let's check to see if that works. X times x, x squared, negative 3x minus 2x, that's negative 5x, and negative 2 times negative 3 is positive 6. So that works yet again. Okay, let's take one last example here. I'm going to take x squared minus 7x minus 8. Okay, so set up our list here. So my numbers have to multiply to negative 8. So again, let's keep in mind, one has to be positive and one has to be negative. So make sure you remember that as you're determining what your numbers should be. So let's write out our possible factors. So well, we got 2 and 4 is 8, and then we've got 1 and 8. Okay, the obvious one there. So let's see what happens, keeping in mind that one of them has to be negative. So I have to have these add up to negative 7. Well, there's no way with 2 and 4 that even with one negative that I'm ever going to get negative 7. Let's take 1 and 8. Then I realize, well, if I take 1 and I add negative 8, in other words 1 minus 8, well, 1 minus 8 is negative 7. So there we go. We have our numbers. M would be equal to 1, n would be equal to negative 8. Right? So our factorization here would be x plus 1, x minus 8. So let's check this out. X times x, x squared. Here we have negative 8x plus 1x. So negative 8 plus 1, yeah, is negative 7. And then positive 1 times negative 8 is equal to -8. Okay, so it looks like we found our method for factoring these types of expressions. Okay, this is going to be equal to a product of two binomials, let's say x plus m times x plus n, okay? But the condition is that the middle term has to be the sum of these two numbers, and the last term needs to be the product of those two numbers. Okay? So this is the rule that you should be working with. Okay? And one word of warning, just because you have an expression in this form, it doesn't mean it can be factored all the time. Not all of these expressions can be factored, but quite a few of them can. Okay, so please do as many examples as you can in order to learn this.